Hello everyone. Now today we are going to see the next topic from our unit number 4, and the topic is hidden surfaces. So we are going to cover the introduction part of this hidden surfaces today. So up till now what we have seen is in our unit number 4, first of all we have covered the topic named as a light. After that we have covered the topic after the light and different illumination models of the light that we have seen. After that we have moved towards the different color models. So in the different color models we have seen the things like the different RGB models, RGB model, CMY model, then HLS, HLV. These are the different color models that we have covered in this unit number 4. Then we have moved towards the next topic of that unit is nothing but a shading algorithm. So we have seen the different shading algorithms in this same by using this concept of light and colors. We have seen different shading techniques, and now today we are going to move towards the next part of this unit number 4, or we can say the last part of a unit number 4, and that is nothing but the hidden surfaces. So today we are going to cover the introductory part of this hidden surfaces, what is called as a hidden surfaces, how we are going to recognize that, and what we want to do if we find out this hidden surfaces. That things we are going to cover here with this topic of hidden surfaces and introduction. So moving forward, first of all we'll see what is the hidden surfaces. So now we are looking some object A. As you can see in the figure, there is one object and viewer is looking towards this object. Then some other object, say like a B, it comes in between our eye and that object A. So this can be a scenario that is shown by this image. We can see that. So this is my object A, and here is the viewer that viewing the object A. So this is object A and viewer is on this side, and we are looking to this object. When one another object named as a B come in between the object A and a viewer, then what happens, that we are going to see. And whenever such a situations occur, then in that case we are not able to see the object A fully. So it may happen that the object may see or may look partially, and it may happen that the object is not visible at all. So these are the different concepts that we are going to learn today. So either that object is not partially visible, it is not fully visible. So this situations may occur, and in that case what need to do, that we are going to see in this hidden surfaces. So it means that the object B is what? That object B is interrupting the projected path from which we have done the projected path from the viewer eye towards this object A. We are taking the projections from our eye to this object A. So whenever we are doing such a thing, our projection path will be disturbed or interrupted by this object B. So whenever such a thing happen, in that case the some surfaces of an object B are also not visible, because they are eclipsed by the object B's visible part. Means what? If you are looking towards this object B, you can see only the 3 surfaces of that cube are visible, and another surfaces are still not visible because they are eclipsed by their visible parts. Means they are hidden due to their visible parts. So whenever such a things are happen, we are looking towards the object A, and in between that object A we are interrupting, we get interruption from the object B. Still we are looking some part of the object B, and the another surfaces of the object B are not visible, and due to this object B we can also not able to see the object A. So such a things are happen, and according to this we are going to identify which are the hidden surfaces, and due to which surfaces we are getting some hidden surfaces. So whenever such a situations occur, we are only get the object B, and we can only see the some surfaces of the object B. So the surface that are blocked or that are hidden from the view, that must be removed in order to construct a realistic view of the 3D scene. Means whenever we are looking some object that is a 3D in a nature, and at that time some of the surfaces of that object may get blocked, or they may get hidden, then whenever we are implementing or we are constructing its a real view on the 2D plane, then we have to remove such a hidden surfaces, because we are not able to see that surfaces. That all things we have done in the engineering graphics, that whatever the front view we are looking, whatever the top view and the side view we are seeing, that only we are projecting on the paper, because the hidden surfaces we are not considering. So we have to identify such a surfaces and then we have to remove that surface. So the object B should be displayed with only the 3 of the 6 faces. So we can see here that the cube is having the 6 faces, right? But here only 3 faces are visible, that are 1, this is 2 and this is 3, and all the dotted lines are showing the hidden surfaces of that cube. So the identification and the removing of these surfaces is called as a hidden surface problem. So hidden surfaces are nothing but the surface which are blocked and hidden from the view, that are called as a hidden surfaces, and whenever we are identifying such a surfaces and removing them, then it is called as a hidden surface problem. And then we have to determine that which are the closest hidden surfaces along each projection lines, means which are the near hidden surfaces for this point, this line that we are going to determine here. So there are many hidden surfaces algorithm we are going to see today, or we are going to see in this topic of hidden surfaces, but most of them, they are categorized according to the image space method and the object space method. So these are the 2 different methods that are used for the recognition of the categories of the hidden surfaces algorithm. So in the image space method, the pixel grid is used to determine the visibility at each pixel level. Whenever we are going to find out whether this surface is visible or not, at that time, for identification of such a hidden surfaces, we are going to use the pixel grid to find out whether they are visible or they are invisible. So pixel level information we are going to observe over there, and that model is called as an image space model. While whenever we are going to considering the object space method, then surface visibility is determined using the continuous model in the object space. So here we are going to use the surface visibility. We are not working on the pixel level, but we are going to work on the surface visibility, and that will be determined using some continuous model in the object space, and that model we are going to see over here. So first of all, we'll see what is the back face removal, means whatever the back face that we are not able to see as an viewer, then we have to remove such a back faces, and that we are going to see first of all. So in the back face removal, the object surface that are oriented away from the viewer, that are called as a back faces, means which are very far away from the viewer point of view, or from our human eye, the surface which are very far away, which are oriented away, that we are going to identify as the back faces, and then we have to remove such a back faces. So the back faces of a cube are completely blocked, or they are completely hidden by the cube itself. So we have seen the example previously, that in this example we have seen the object is hiding their back sides, right? So this front surfaces 1, 2 and 3, they are hiding the back surfaces of that cube itself. So that example we can consider for this back face removal, and therefore we can identify and remove such a back faces, and for removing such a back faces we have to consider the equation of a plane. So in this computer graphics, we are started with the lines, then we are moved towards the circle, then we are moved towards the polygon, and then how to fill that polygon, and how to clip the line, how to clip the polygon, how to color the object, how to give the different shadings to the different objects, that all the concept we have seen, right? So whenever we are moving from line to polygon and any circle or anything, we have always considered the equations of that particular thing. So whenever we have used the line, then we are going through the line equation, then we have moved towards the circle, then we are using the circle equation, then we are using the polygon equation, right? So now we are going to use the equation of a plane, because here we are going to consider the x, y and the z coordinate for calculating whether the object is oriented away from the viewer or it is very near to the viewer. So for that purpose we are going to work on the equation of a plane. So how the equation of a plane is mentioned? The equation of a plane is given as, which plane we are considering? The 3D plane. So 3D plane, the equation will be ax plus by plus cz plus d is equal to 0. So ax is nothing but it is related to the x axis, by is nothing to the related to the y axis, and cz is nothing but related to the z axis, and d is nothing but a constant. So this is what the equation, we have marked this equation as a 1. This is nothing but the equation of a plane. Ax plus by plus cz plus d is equal to 0. We have marked as a equation number 1. Now in the object space method, the identification of the back faces is based on the equation. So whatever the equation we have marked as a 1, we are going to find out the back faces depending upon that equation of a plane. From that equation we can say if any point xyz satisfy the equation, then the point xyz is lying on the plane. If that point, any point that we are going to consider is having its coordinate as a xyz, if that point xyz satisfying the equation of that plane ax plus by plus cz plus d is equal to 0, if that is satisfying the equation, then we can say that the point is lying on the plane. But if we are putting that value, and if the value is less than 0, if we are putting that xyz in the given equation, and if that ax plus by plus cz plus d is less than 0, then it means that a point xyz lies on the negative side. It is lies on the negative side. And if that equation x plus by plus cz plus d is having its value greater than 0, then we can say that the point xyz lies on the positive side. So this is what same related to the if we are considering the circle, and we are same way, if the equation of a circle is satisfied, means it gives the value as a 0, then it will be point on the circumference of the circle. If it is less than 0, then point is lies inside the circle. If it is greater than 0, then point is lying outside the circle. In the same way we are considering for the plane. If it is greater than 0, then the point is lies on the positive side. If the equation is less than 0, then point will be on the negative side, and if it is perfectly equal to the 0, then point will satisfy and it is lying on the plane. So this is what the different techniques to find out whether the point is on the positive side, negative side, or it is on the plane. In that way we can find out by using the equation of a plane. So we have marked them as a 2 and 3 according to their visibility, whether it is on positive side and negative side. We have marked as a 1, 2 and 3 equation number. So if we consider any point, for example xyz as a weaving point, then any plane which satisfy the equation number 2 must be a back face. Equation number 2 means the point which is lie on the negative side. The point, if we are getting any point which is lying on the negative side, then we are considering this point as a back face. Okay. So if this point xyz is satisfying the equation that is less than 0, then we are recognize that as a back face. So we are considering that point or that face as a back face. So after finalizing the back face, such a back faces, we have to remove that from the further visibility. So here we can see that if we are considering this point that ABC, so the color part or a color portion showing the back face, because it is lying on the negative side. You can see here the minus z is given, and that's why they are on the negative side, and that's why we are considering them as a back faces, and we have to remove such a back faces. After that we have to look at the few algorithms of the hidden surfaces here. But before going towards the hidden surfaces algorithm, the most of the algorithms that we are going to use for the same, they are going to use the concept of depth comparison algorithm. So let's see what is this depth comparison algorithm. So first we have to try to understand the concept, the depth comparison, and then we are going to use this in most of the hidden surfaces algorithm. So the hidden surface algorithm must be capable of finding the edges or surfaces which are visible. So here we are going to find out such as surfaces or the edges that are visible. How we are going to find out? We can see here in this diagram. Suppose we are having the 2 points. For example, A is equal to x1, y1 and z1, and B is equal to x2, y2 and z2. These are the 2 different points. Now we are going to see that whether these 2 points, both points are visible or not, whether one point is hiding to another point or vice versa. So if we want to know which point is getting hidden out of A and B, then in other words we can say that whether point A is hiding to point B or vice versa, means B is hiding to point A. So for this we have to apply the different two steps. So whenever we are going to see that here, if we are considering A is the point which is x1 y1 z1 and B is the point x2 y2 and z2, and these are the two different points which are not lying on the same line. So if we are giving the projections to this line, if both points A and B are not lying on the same projection line, you can see here there are the different projections lines are drawn. This is the line number 1, this is what the line number 2. So two different projections line are drawn here. So we can see here they are not on the same projection lines, so no points will hide to the another point. It means that if both points are not a collinear, then both will be visible. Means if they are not lying on the same line, then the both points will be visible, and therefore we have to take the position of both A and B point on the xy plane for to display. So this point A and B will be displayed over here. It means if they are not collinear, then we have to project this point on the 2D plane, and after projecting this point, A will becomes x1 y1 by deleting z coordinate, and the B will become x2 y2 by deleting its z2 coordinate. So A and B will be displayed on this plane. No points will be hiding to another point. Here we can see it easily. But if the points A and B are on the same projection line, then both points are collinear. Here we can see that both points A and B are on the same line. So either one of these 2 points will get hidden by another, means either A will hide B or B will hide A. So how we are going to consider that which point is going to be hide another point? So for that purpose we are going to use this depth comparison algorithm. How? As both points A and B are collinear, they are on the same line. As both points A and B are collinear, the projection of the both points in the 2D plane, we can see here only one point is projected. So how we are going to say that a single point will be displayed and which point we have to display, whether it will be A or a B. So in such a cases it happens that x1 and x2 are equal, y1 and y2 are equal, and we have to not consider z1 and z2. So here we are finding out whether A should be displayed or B should be displayed according to our z value. So whether this point will be A point or this will be a B point, that will be depends upon the z value. So how we are going to find out that again? So z value, for that we have to use the third parameter, that is called as a z coordinate. So this z coordinate is nothing but it is also called as a depth. So if z coordinate of a point A is a smaller, a point A, that is z1, is smaller than the z coordinate of a point B, that is z2, then z2 is in front of z1. It means point B will hide to the point A. Very simple. If we can say that the z1, which is nothing but z coordinate of a point A, if z1 is smaller than z2, that is a z coordinate of a point B, then z2 is in front of z1, means it is near to the viewer, it is in front of z1. So it means the point B is hiding to the point A. If the z1 is greater than z2, then in that case the point A is hiding to the point B. So in this way we are recognizing whether A is hiding to the B or B is hiding to the A. Means when z1 is less than z2, then in that case the z2 is near to the viewer, means point B is visible. Okay, so in the 2D we have to plot the point B only. So we can recognize here that z2 is having the smaller value than the z1. So we are plotting the point B here. So we are assuming that the viewer is on this side and the z2 is greater than the z1. So we are plotting the B point over here. So in this way we are going to consider which point is hiding another point, which surface is hiding another surface. So in this way we are going to come to know the thing. So in this way we can display our points. So which kind of questionnaires can be asked on this topic? So what are the hidden surfaces? First of all you have to say that what is the hidden surfaces, and then you have to describe what is the hidden surface problem. So the identification and the removal of hidden surfaces is nothing but the hidden surface problem. And then next is explain the backface removal algorithm. So we have seen the backface removal, how we are going to remove the backface. For that we are using the equation of a plane. When it is less than 0 or greater than 0, then it is on the negative and the positive side, that we have to explain here. Then explain the backface removal with the help of examples. So you can draw the diagram, and you can show that the faces which are on the negative axis, we have to consider them as a back faces. That is also we have seen. And the last question is how the depth comparison algorithm is used for the to find the hidden surfaces. So we have seen that in the depth comparison algorithm, we are finding out the point Z1, which is the point Z which is near to the viewer or which is far away from the viewer. So according to this comparison of Z coordinate is nothing but the depth. So we are comparing Z coordinate, means we are comparing the depth, and that's why its name is a depth comparison algorithm. So here according to the comparison of Z coordinate, we are finding out which point is heading to another point or which surface is heading to another surface. So this is called as a depth comparison algorithm. So with this topic we have covered with the introductory part of the hidden surfaces. So we will stop today here. Thank you all of you.